Okay, find the volume of the solid obtained by rotating the region that's bounded by y equals log x, y equals 0, x equal e. And we're rotating this about the x-axis. All right, volume question. So we're going to need to draw the graph. That'll be our first step. Let's draw the graph. So log x crosses at x-axis at 1, has the following red graph there. X equals e is a vertical line, and y equals 0 is the x-axis. And we are rotating about the x-axis. We make that dashed. When you do this, you should make a second copy and decide which method to use. On one graph, you should draw a rectangle that is perpendicular to the axis of rotation. And on the other graph, you should draw a rectangle that's parallel to the axis of rotation. Let's deal with this one here that's perpendicular. Notice how when you move that from left to right, it's flush up against the axis. There's no gap at all. So that's going to be the disk method. So because the rectangle is upright, it's going to be an x. Okay? Volume with disk is you take the radius and you square it. But for us, the radius is the distance up to the function. And that's going to be the log x. And so it is going to be the quantity of log x that gets squared. And this thing would move from left to right. Not at 0. It doesn't start at 0. It starts at 1. And it's done by the time you get to e. So pi times the integral from 1 to e of the natural log of x quantity squared. That's different than the natural log of x squared. And so those are two different things. And so we want to be able to integrate that. Let's try to set it up the other way. Maybe this is something that we can't figure out. Try to set up the other way where we set up a rectangle that is parallel to the axis of rotation. That parallel is going to be shell. Since the rectangle is horizontal, it's going to be moved upward, so that's a dy. You have to integrate it in terms of y. And so what we need for shell is a radius and a height. The radius is what you get by attaching the axis to the rectangle. And so that distance there is the distance off of the x-axis, and that's y. Since your integral is done in y, it's going to leave it as a y. Okay. Now, the height is the rectangle's height. And for this, we'll do the right minus the left. So the right takes you all the way to e. So it's like x equals e. The left takes you to the curve. But the curve is called y equals log x. So you have to solve for x. And so we have to call that e to the y. If you're taking this and trying to solve it for x, you e to the left and e to the y right. And then e and log cancel. So x is equal to e to the y. And so the distance off the y-axis is called x. And the distance off the x-axis is called y. And this is what we were looking here for. X equals e to the y. So e to the y is our second part that we subtract away from e. So we do e minus e to the y, and that will be our height. This thing moves upward from a low bound of 0 to a high bound of 1. When x is e, log of e is 1. Where they intersect that, the y value would be a 1. And so this integral is the product of these two guys, y times the quantity of e minus e to the y. They'll give us the same result. Looking at them, we need to decide which one to do. It turns out that we're going to do both, and you get to decide which one you like better. I want to show you how to do both. Let's start with the disk. You see, this is very different than the natural log of the natural log x quantity squared is not the same as the ln of x squared. There's a property that you can do with the ln of x squared that you can pull the 2 down in front, but you can't do that with the whole quantity ln x squared. It doesn't work that way. And so we have to use integration by parts. Now, usually with integration by parts, you don't do it if there's only one term, but what you do is you sort of insert a 1 in there, and then think about that as being your second function. And so you let u, because of the hierarchy, because of the mnemonic, logarithm functions get to be u first. So u should be the natural log of x quantity squared. Be careful, that's going to be difficult to take that derivative, but you can do it. And then the dv part is the rest of it, which is just 1 du, 1 dx. So we differentiate to get du, and we integrate to get dv. Now, to take the derivative, we have to bring the 2 down in front, take the thing to the 1 power, and then multiply by the derivative inside. Chain rule, 1 over x. So that's the derivative. And now the other side, we integrate in 1, and just get x. I got to put the pieces of the puzzle together. I like to draw these 2 little things in here to remind myself that I'm multiplying u times v, and then I'm multiplying v times du. So u times v would be x times the quantity of log x squared. And then just writing it all out, I have a 2 log x over x. That's what this guy is. And that's times an x. And so those guys cancel out. And I can pull the 2 outside. And now my new integral, this blue integral, I had a log of x quantity squared, and now I have a log of x. I've gone down in power by 1. So I can do it again. Or maybe by this time you remembered that the integral on log of x is x log x minus x, I believe. But we're going to work it out. Okay, let's just work it out. Let's figure it out on the next slide. Well, here's where we're at right now. And now we're going to work on the blue integral. Choose u to be log. dv would be, the 1, put the 1 in there again. So 1 dx. And then the derivative of u is 1 over x. You're going to differentiate u to get du, and you're going to integrate dv to get v. So we differentiate here, we get a 1 over x. We take the integral here, and we just get an x. Put these little signs here to remind yourself what you're multiplying. And so u times v minus the integral of v du. So x log x minus the integral of x times 1 over x. Hey, they cancel again. And this is just the blue part. It's just, we still have the other stuff still there. The pi is still there. We'll put that back on. And then there's the x log x from the uv, and then the v du integral. Is an integral that you already did. It's the integral of 1. You can put the 2 in if you want to distribute it. And so we end up with x, 2x actually. So we've done our antiderivative. X times the quantity of log x squared minus 2x times log x plus 2x. That's our integral. And now it's our job to go back, put the bounds in, and put the pi back in, and get this final result, which is the volume. So we put an e in every place we see an x. So there, and there, and there, and there, and there. Put a 1 in every place we see an x. I like to add this step in. You don't have to do that, but nice. Log of e is 1. Log of 1 is 0. So you get e minus 2e plus 2e. You get 1 times 0 minus 2 times 0 plus 2. So these guys cancel out, 2e and 2e. These guys are zeroed out anyway. Distribute this minus. The answer to the question is pi times e minus 2. This is volumes, units cubed. And that was doing the disk method. Okay, nothing wrong with that. Worked out nice. I will also show you the shell method, the working out of that. It was y for the radius, and e minus e to the y for the height. And that's y times e, distributing, and y times e to the y. Now, y times e looks a little strange, but it's a constant times y. So y squared over 2 would be the antiderivative of that. And then the y e to the y is a different animal, though. That's going to require integration by parts. 2 functions multiplied by each other. It's going to require integration by parts. So I put that one in blue. I'm going to integrate that by parts. Let u be y. It's a no log, no inverse trig. This algebraic function y is going to be what u is. dv is the rest of it. The derivative of y is 1. The integral of e to the y is e to the y. And remember now, we're going to multiply u and v together. and subtract the integral of v du. So we get y minus the integral of e to the y, which is, e to the y. So y minus ey. Put a 1 in, we'll be done. The other integral is just e is a constant, and the integral of y is y squared over 2. So we put a 1 in, put a 0 in to both. So we'll have e over 2 minus 0, and then we'll have e, 1 times e minus 1 times e. Hey, these 0 out. And then 0 minus e to the 0. Now, be careful. This e to the 0 guy is a 1. And the minus minus is a plus. So you got the 2 pi and get e over 2 minus 1, and putting the 2 in, you get e minus 2 pi. Same answer, just done a different way. And you get to decide which one you like better. Maybe the log x quantity squared was too much, and maybe this is more straightforward. They're both integration by parts. The log x quantity squared required it twice. Okay? All right, great.